Okay, last time we covered the statewide counting program. We did some examples with the calculation of adjustment factors for different days of the week and different months of the year. Okay, and we did it using the permanent control count as well as major control count. Okay, and then we looked at one example where how we can combine different control stations together, combining in the form of their adjustment factors. So the rule was if the difference between the values and the adjustment factor is more than plus minus 0.1, you cannot combine them. If it is less or equal, we can combine them. Okay, this was the example where we just did the one check for one iteration only, and I told you you can see which station has more values out of the rule, and you can try to combine the other stations which are less problematic. Okay. What do we do with these adjustment factors? We calculate the adjustment factor for every day of the week, every month of the year. Then what do we do with them? Okay, why are they required? Okay, they are required to calculate AADT for the coverage counts. Okay, what is the difference between control and coverage?
Coverage will take part of the time, control of time.
Okay, but for statewide program, even the control may not have the full count, but it is more than the coverage. Control is more than the coverage. Okay, so when the count is less, so you only took the count for 1 day. Now from 1 day, how can we calculate the annual average, right? We cannot do it. Okay, got it? So then we use the adjustment factors to calculate this annual average. Okay, how? We use this equation. So for example, you have the count of 1 day. Okay, V24 means a count of 1 day. Okay, you know which day of the week was it. Let's say it was Thursday. Okay, and you know this count was taken in which month. So let's say it was taken in October. Okay, so you will take your count, multiply with the adjustment factor of Thursday, and multiply with the adjustment factor of October. Okay, after this multiplication, it will become the annual average. Okay, so these adjustment factors are used so that we can convert the count of the coverage to AADT. Okay, there. So for example, let's say for a control count location, they calculated these factors. So you can see factor for every day of the week and every month of the year. Okay, and now they in the same network. Okay, remember, in the same network. So this control is a part of the network. Okay, so in the same network at some other location, they took the count of 1,000 vehicles on a Tuesday in July. Okay, for this location I only have this value, one value. Okay, so I cannot calculate AADT, or I cannot call it AADT. Okay, so I have to convert this into AADT using the factors, okay, for the day and the month in which it was taken. Okay, so the count is 1,000 vehicles. AADT will be 1,000 into when it was taken, Tuesday. Okay, so the factor is and which month it was taken? July. Okay, so for July the factor is okay. So the AADT for this location is how much?
10.5.
Clear? Okay. So the main idea is to use the adjustment factors to calculate AADT for locations where we have less data, meaning the coverage count location. Okay? Clear? Sure. Where is the notebook? Where is the notebook? Okay. Another example, now we have 6 locations. Okay, on every location you can see the count is for 1 day. The table on the right hand side or the left hand side. Okay, so in that table you can see 6 locations. Every location has a count of 1 day. When was that day? It is mentioned. In which month it is mentioned. Okay, and for these days and months the adjustment factors are right here. So what we need to calculate is the AADT for each one of them. Okay, and then we will calculate vehicle miles traveled. Okay, vehicle miles traveled, I explained it last time. We get it by multiplying what? 2 things. Distance and time. So if this question comes in the exam, all of those people who are absent in this class, they are supposed to get full marks, right? They deserve this for being absent. Doesn't even happen in the schools. I was absent. You have not. Okay, tell me.
The average count of vehicles.
Counting of vehicles. Okay, count of vehicles. This applies to everybody. Okay, people who are laughing and who feel and don't feel applies to everybody. You cannot say I was not there. Okay, so first question is why were you there? And if you are not there, you are supposed to catch up. Okay. Nobody will come and give you tuitions separately. Okay, you have to catch up yourself. Notes are there, the videos are there. You have to make it happen. Okay, everybody. There. Okay. So VMT means distance multiplied by the count of vehicles. Okay. Now in this question they are asking for VMT for 365 days. 365 days meaning what? The whole year. Okay. So I cannot again for 365 days. I cannot use this value. This is for 1. Okay. So if you want it for the whole year, I should use the average count of the whole year, right? And that average count is what? AADT. Okay. So first thing is I need to convert this into average count. Okay, how do we do it? No. Call them adjustment factors. These are adjustment factors. Okay, expansion factors are something else. We studied in limited network. They are not here. Okay, only adjustment factors in the statewide program. Okay, so we will use the adjustment factors, right? So adjustment factors will convert them into AADT. Okay, then VMT is count multiplied by distance, right? So distance means the length. The length of each segment is given. Okay. And why multiply by 365? Because we want it for the whole year. Okay. If you don't multiply this, if you just do this, this is average VMT of 1 day for the whole year, yes. But average of the whole year. Okay. This makes it total. Clear? Yes. Clear? Okay. So segment we have 1, 2, 3, 4, 5, 6. Okay. AADT, then VMT 3, 6, 5. So AADT, for example, if you take the first one, Wednesday, March. Wednesday, March. Yes. How much? Okay, next one. Tuesday, September. Yeah. Yes. About? Yes, next one. Okay, next. 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 Okay, now to calculate VMT, you take the value from this column, multiply by length, which is here, multiply by 365. Okay, how much? One two 171700925. Okay, next. 65. Next. 131. Done. Okay, which section has the highest VMT? So what do we say about section 4? Huh? It has higher demand and longer distance. Okay. So what does it make? Okay. Okay, I look at the distance, I look at the demand. Control. No. VMT, what's the purpose of VMT? What does it indicate? What does it indicate? VMT tells you about the importance of the segment. The segment with the highest VMT is more important for the travelers. Okay? Segment 4 is more important. Okay, most important among these for the travelers. Okay, and the reason could be more distance or more demand or both. In case of segment 4, it is both. Right? The least is what? Which one? 5, right? Okay. For segment 5, does it have the least distance? No. Does it have the least demand? No. Okay. So that's why we combined them, because it can be confusing. If you are looking at these two things separately, you may get confused that which one is more, who should get more priority, more importance. Okay. So that's why we came up with VMT. So we combine them, and then whatever the product is, we decide on the basis of that. Okay. So nobody can say, okay, you are saying it's least length, but look at the demand as well. Okay, you are looking at the demand only, look at the distance as well. Okay, so we combine both of them, so we don't have to worry about two things at a time. I'm only looking at what VMT. Clear? Clear? Okay. Moving on to specialized counting studies. Okay. These counting studies give you the demand for an area. Okay. These counting studies give you the demand of traffic for an area. Okay. Up till now you are not dealing with demand, you are dealing with volumes. You are dealing with volumes. Yes, you are trying to get the volume in different ways so that we can get an indication about the demand for one segment, for an intersection, for a network, but it's just an indication. The real demand doesn't come from there. Okay, I explained it, I think it was chapter 2 or chapter 1. I explained at that time that the actual demand may not be on the road. Okay, the actual demand may not be on the road. Maybe for some people, Dr. Unnam announced that I will not take the class in section 2, so will not come at all. Okay, but those people are part of the regular demand, right? Okay. Some of them, instead of coming here, they went to the medical center, right? To get the help, excuse and so on, right? But they are part of the demand, right? Okay. Regular demand may not be on the road itself. Okay. So these specialized counting studies will help us find out the actual demand for an entire area. Then we do some other process to get or to divide the demand into different segments or highways. Okay. So we are just looking at the first part of this whole process of demand. Okay. The first part will give us demand on the area. Okay, for the entire area, not for every highway or segment. That will come after. So there are three methods to do these specialized counting studies. Okay. Starting with origin and destination counts. Okay. Origin means what? What is an origin?
It's like
The people of every big franchise.
it's like when you live there or
Yeah.
follow them.
Start of your trip and destination is desired area, judgment day, right? Destination. Okay, so origin the start and the destination is the end of the trip. Okay. Now when we say trip, we mean both ways. Okay. Both ways. So your trip or your trip is you are going from here to education, from here to work. Okay. And obviously you will come back. Obviously. Okay. So this is understood that you went from home to your office or to university or to school, and then you will come back, but your origin is home and your destination is that one. When we say trip, we are taking into account the whole process, okay, the entire process of going and coming back. Okay, so you went from your origin to your destination, and then you came back to your origin. So home is the origin. Okay, so it's not like, okay, in the morning it will be this and in the evening you will flip it. No, home is the origin, destination is the work or education or shopping or whatever. Clear? Okay. To do these studies, we have three methods. We have three methods for origin destination counts. License plate studies, postcard studies, and interview studies. Okay. In license plate studies, first of all, in all these studies, in specialized counting studies, the first thing you have to do is establish your area for which you are finding out the demand. In all the specialized counting studies, you have to establish your area. So this city is my area, or this country is my area, or this state is my area. Then this area will be divided into different smaller zones. So in this city, I will divide the whole city into maybe 4 or 5 zones. Okay. So in the end, I will get the demand of each zone. Alright. So you have a big area, and the area is divided into smaller zones. Clear? Okay. So and this is what we do in all specialized counting studies. Mark the area and then divide it into zones. Clear? Okay. In license plate study, what do we do? From one zone to another zone, there must be some connection, right? There is a highway which is going from zone 1 to zone 2, right? There would be a highway which is going from zone 2 to zone 3. So there will be entry and exit points for each zone. These entry and exit points are the highways. Okay. So on these entry and exit points, you have your observers, and they are noting down what? They are noting down license plate. Okay. This car exited zone 1. This car entered zone 1, and so on. Okay. You can have multiple observers on the same point depending upon how many lanes and how much demand is. Clear? Okay. So after they collect this data, they will go back to the office and they will match, okay, the license plate numbers with each other. Okay. So the guy who was at the exit of one zone, he will say this car went out from this zone. So they will look for the other observers. Where was this car found next? Okay. Was it found next entering zone 3 or zone 4? So the zone from which it was exiting becomes what? The exit zone becomes origin, and the zone where it entered last, it becomes destination. Clear? Okay. So you will know the origin and the destination. Next one is postcard studies. Okay. In postcard studies, we are asking the question to the user or the traveler himself or herself in the form of a card. Now we don't need the card, or you can still give them the card with a link or a QR code or something, so they can answer your questions. Okay. So back in the day when they didn't have these tools, they used to give the card. Okay. They will write on the card origin, destination, from which zone they are coming, which zone they are going. Okay. And then they will post it. So that's why we call them the postcard. Okay. So you give them the distribute the card and you go home. Okay. Whoever fills the card and posts it, you will receive it. Okay. You will see his or her information. So all the cards which you get, you will have the origin and the destination from these cards. Clear? Okay. Next one are interview studies. Again, we are asking the user, we are interviewing them. Okay. But interview studies have more information. Okay. And interview means what? Face to face. Okay. Face to face. So they take longer, and you will get more information and so on. But part of that information is always what is your origin, what is your destination. Okay. You may ask them, okay, what is your origin destination for the work trip? What is your origin destination for the shopping trip? What is your origin? can ask more questions, okay, get more information, okay, and it is face to face, yes. Clear? Okay. So once you get the information from any of these methods, you will prepare a matrix. We call it origin destination matrix, OD matrix. Okay. So 1, 2, 3, 4 is what? The zones in your area. Okay. So they are listed as the origin and they are listed as the destination. Some people are living in those zones. For them, they are the origins. Some people are working in those zones. For them, it is the destination. Okay, clear? So, who are these 50 people? Their origin is zone 1, destination is zone 1. Okay, I have a friend like this. Like, he studied near his house. The university was near his house. Now he is doing job there. He never left that area. I hate him. Okay. And then for these guys, they are coming from zone 2, going where? 1. If you want to find out the total number of people who are coming out of a zone, you will do what? Summation of columns. Total number of people who are coming out of zone 1, these, right? And if you want to know the total number of people going into a zone, summation of the rows, right? Clear? Okay. So these are the summations. Okay. But there is a limitation of these studies. They only give you an idea about the actual demand. They only give you an idea about the actual demand. Okay. Why? Because you use any of these methods, you will not get 100% data. Can you do 100%? Can you do interview of 100% people and the entire area? No. If you give postcard or you send links or QR codes to people, will everybody reply to you? No, right? Even your friends don't, right? Get rid of them. And license plate number. License plate method. We already discussed in the travel time case. You are writing the license plate number. There are some cars which you will miss. So no study out of these methods can give you 100% data. Okay. So how can I make my data more accurate? There is always some error, right? We are engineers, we know that. Okay. There is always some error. Okay. I cannot completely eliminate the error, but I can reduce it. Okay. So what do I do for reducing the error of this matrix? We do a field study. Okay. On the entry and exit points of all the zones again. In the field study, we are not asking anything. We are not noting down the license plate number. We are just counting. Okay, counting cars and people. That's it. Okay, so how many cars and people exited, how many cars and people entered. And then we write it in front of each zone in that matrix. Okay, so the people who were doing the study, the field study, at zone 1, they found 250 vehicles entering zone 1, destination, right? Entering. And they found 210 vehicles going out from zone 1, so origin. Clear? Okay. So I have a result from my matrix which gives me how many people exited and entered, and I have a result from my field study. How many people exited and entered? Okay. Are these numbers equal? They are not equal. Huh?
Difference is not.
Yeah, and the difference is too high, right? It's not even 100 and this going above 200, right? So it's 2-3 times. The difference is 2-3 times, not 2-3%. Okay. So we will try to minimize this. Okay. For that, we'll do the calibration of the matrix. Do the calibration of the matrix. What do we call the matrix? OD. OD meaning overdose, right?
Origin, destination.
Origin, destination. Okay. So we will change we are doing origin destination count, right? So we will calibrate the matrix so that our origin destination count becomes more accurate. Field study will remain as it is, we will not change it. Okay, so what do we do? What is the method? For every row and column, do volume upon summation. Volume which you got from the field and summation which you got from every row and column. Okay? So 210 upon 88, 200 upon 99, this upon this upon this. Okay? Similarly, 250 upon 95, 310 upon 106. Okay? And so on and so forth. Clear? Clear? Okay. We are trying to make these numbers equal, right? We are trying to make these numbers equal. So the ratio will become what? When they are equal, the ratio will be 1, right? We are trying to make it 1. Obviously, now it is not 1, right? It's 2 and 3 and so on. Okay? And what do I say about the error? The error will always be 0. Yeah, I give you F, error is 0. But the error will always be there. Okay? So you cannot make it exactly 1. You cannot make it exactly 1. So we have a margin. Okay? 0.9 to 1.1 acceptable. If the ratio is 0.9 to 1.1 acceptable. Okay, clear? Okay. Now if I calculate the ratios for these, you can see the ratio. Okay, these are ratio 2 point something, 3 point something. Okay, I'm trying to make it what? Close to 1, right? Okay, and they are not even in the range, right? What is the range? Huh? What is the range of this factor which is acceptable? Yeah, 0.9 to 1.1. Okay, so now it is not in the range. Okay, how do I make it in the range? For every number in the matrix, remember we are calibrating the matrix. We will not do anything with the volumes. Okay, volumes will remain as it is from start to end. Okay, every number in the matrix, let's say the first number is what? 50. 50 is in the first column and the first row, right? I'll take the ratio of the first column and the ratio of the first row in which number is. Okay, and multiply 50 by the average of the ratios. Okay, so it will be but let me put it there. Okay, so 50 multiplied by the average of the ratios of the row and column. Clear? You will get a new number, right? So that number will replace 50. So instead of 50, it will become 100. Clear? Clear? Okay, and this will be done for the whole matrix. Okay, so you will do the same thing with 8 as well, and 10 as well, and 15 as well. Got it? Okay, the factors will be taken from that row and that column. Okay, so for 8, you will take the average of which factors? 2.02 and 2.6. Clear? Okay, and 8 will be replaced by the number you will get after multiplying with the average. Okay. Okay. Clear, everybody? Okay. So they did this for the whole matrix, and this is the new matrix which they have got. The previous matrix is replaced by this one. Every value in the previous matrix was multiplied with the average of the factors in row and column. Clear? Okay. Any question up to now? Okay. So you got the new numbers now. When you get the new numbers, obviously summation of each row and column will change, right? What about the volumes? Same. Never change. Okay. So I will now recalculate the ratios with the new sums, okay, which they have done. Okay, you cannot see it for the column, right? It's done for the row and column both. Can I change it? Okay, so these are the new ratios according to the new sums. Okay, so how did I get 0.9? What upon what? volume upon the sum, 210 upon 232. Okay, similarly, how did I get 0.94? 250, sorry, yes, 250 upon 260. Clear? Clear? Okay. What is the acceptable range of these factors? 0.9 to 1.1. Are they in that range? Not all. All of them are not in the range. Okay. So I cannot exclude any row or column. My matrix must be complete. And when I do the calibration, I will have to calibrate the entire matrix. I cannot do calibration for one row or one matrix. Because if you do it for one row, you are changing all columns, right? One row will change all columns, right? And if you are doing it for one column, it will change all rows. Okay, so you cannot exclude any row or column, and you cannot do the calibration for a particular row or particular column. Okay, so my problem is here. This one, and this one, right? Two columns and one row. Okay, but having said that, when I will recalibrate the matrix, I will do it for the entire matrix. Okay, so now I will use these values and these ratios now. Okay, so for example, 125. What will I do with 125? Tell me. 125 multiplied by what? 0.9 plus 94. Okay, this will give you the number to replace 125. Okay, same thing with the next one and the next one. Clear? Okay, so you will replace the entire matrix, then you will redo the sums for each row and column, and with the new sums you will recalculate the ratios. So this is what they have done here. Okay, the replaced matrix, the new submissions, and the new ratios. Okay, clear? Okay, are they in the range? No, not all, right? How many were out of the range previously? 2 columns and 1 row, right? How many now? 1. So it's getting better, right? It's getting better. So this is like a check. If you are getting worse results in the previous try, you made a mistake. Okay? If your results are getting worse, meaning it was, for example, one factor was 0.9, in the next one it becomes 0.8. This is a problem. Okay? It should always get close to what? 1. Okay? Clear? So because again, we have a problem with one column, we will do for one column the whole matrix. Okay? And the same thing. You pick each value, multiply by the average of the ratios, okay, and replace the value. These are the new values. With the new values, these are the new submissions, okay, and then these are the new ratios. Clear? Okay? Should we stop here? We can, right? I don't mean the class, I mean the problem. We can stop there, right? Okay, this is done. This is the final matrix we have. This is the final matrix we have. Okay? Clear? So we were asking people about their choice of origin and destination. Okay? We got some numbers, but those numbers did not represent everybody, because everybody was not part of my study. Okay? So how can I make it closer to the actual number? I will do this calibration. For this calibration, I need a field straight. Okay? Clear? Another type of specialized counting study is a cordon count. Cordon means boundary. A boundary. Okay? So this wall can be a cordon. Okay? You see at construction sites they put these orange cones. Okay? Or they put these yellow tapes or something. Okay? These are also cordon. Anything which serves as a boundary is a cordon. Okay? So cordon counts are done inside to know the demand inside an imaginary boundary. Okay, so you don't actually put any blocks or barriers around your area. You cannot do that, right? You cannot. I'm doing my study. Let me build a wall around the city. Huh? Nobody will go up in and out, right? You cannot do this. Okay. If you can do this, let me know. Someone is so powerful in the class. Let me know. So, so you have your area. Okay, you will mark a boundary around this area. This boundary will be called as a cordon. Okay, now what we are trying to find out, how many people are crossing this boundary. Crossing the boundary means either they are going, how many are coming into the area. When they cross the boundary, they will come in, right? So how many people are coming in the area? Okay. So the area inside the boundary must be important for me, right? I'm separating everything and I'm focusing on one area, right? So this area must be important than the rest of the region, right? Okay. So usually these areas are activity centers, or another name for them is CBD, Central Business Districts. Okay. The areas which we normally select, or the areas for which we do the cordon count, they are activity centers or central business districts. Okay, commercial areas. In simple words, commercial areas. Okay, these commercial areas may have lots of stores or restaurants or offices. Get my point? Okay. And normally the demand in these commercial areas is what? Very high. Okay. So these areas then become important for us because they are causing so much demand, and so much demand means traffic congestion, delay, and so on. Okay, clear? So, what do we want to know at the end? Accumulation of vehicles inside the cordon, inside the area. How many vehicles are accumulated? Accumulated meaning what? They are. Accumulation means what? Huh? Together. Okay. How many vehicles are inside the area at a time? Accumulation. Okay. So you have to mark the boundary around the area, right? And you are looking at people who will cross the boundary. Few points you have to keep in mind. First of all, the size of the boundary. Okay. Try to cover the entire area. Don't focus on specific buildings. Okay. Or specific streets. Try to cover the whole area, because the whole area will be affected by the demand. Okay. So if you make a boundary around this campus only and forget about the rest of the area, you are excluding important parts of the road network which are affected by the demand of the campus, right? So we should do this. Okay, try to cover the area so that you cover the parts which are affected by the demand. But try to keep the boundary within or around a uniform land use. Okay, the land use inside the area should be uniform. Meaning what? If the area inside your boundary is commercial, okay, then the entire area should be commercial. Okay, don't make your boundary so large that even the residential is covered also. Okay, so make sure that the area inside your boundary has the same land use. Okay, and okay, so make sure the area inside the boundary has the same land use. Okay, and then you are still covering a sufficient part of the area which is affected by that land use. Okay, it will help you with the planning. You cover all the affected area, but you are covering it for the same land use. So the planning will become easier because I know where the things are happening and why they are happening. If you try to cover too many things, then things will go, some traffic is because of residential, some traffic is because of commercial, some traffic is because of educational. I don't know what to do then. But if I know everything is because of one reason, then it becomes easier to plan. Yes.
Sometimes we have both servers. For example, in the
Normally these areas are then not activity centers. So these areas quadrant counts are not done. Quadrant counts is then very focused. So you don't have to do quadrant count for every area. You are selecting the area, that you select an area which has a specific activity which is very heavy. Okay, and normally those are the areas which have most of the problems. Okay, clear? Okay, size of the boundary, one thing. Secondly, the location where the boundary will cross. Okay, make sure the boundary crosses at the mid blocks, the segments, not at the intersection. Make sure the boundary is crossing the roads at the mid blocks, at the segments, not at an intersection. Because at the intersection, what will happen? People will, they will turn. You don't know whether they are going out or in. But if they are on the segment, I know people are going out or in. Okay, so make sure they are on the segments and mid blocks. They are crossing the road segments and mid blocks. Around some area, I told you, we cannot make the boundary ourselves. I cannot make it myself. But if there is already a boundary there, already an object which is covering half of the area, this becomes my boundary, right? This object will become my boundary. For example, there are countries in Europe where you will have river going around the city. So that river becomes a boundary. Okay, I will take it. Okay. Some cities they have railway lines. Okay. So you cannot just cross the railway line from anywhere. Right? Railway line becomes a boundary. Okay. So river, railway line, even a bridge, maybe a long bridge or something. If any object is already covering the area, consider it as a boundary. Make it part of your boundary. The imaginary line which you will draw around the area, make sure that object is part of it. Okay. Why? To reduce your data. Because you need data for what? People who are crossing the boundary, right? People who are crossing the boundary. So if the boundary is a river, then people will still cross it, obviously. But they will cross it from few points, right? From few points. Okay? The points to cross the river, you need a bridge. Okay? We are talking about vehicles. Don't say I can swim very well. Yes, you can. But you are not part of the city. Okay? So we need a bridge. Maybe there is only one bridge. Okay? So your counting will be only for one point. Becomes easier, right? Railway line, again. You don't allow the people to cross a railway line from anywhere. Okay? They have barriers and signals and everything. Okay? So the whole railway line may have only one crossing point. So your observation is for one point. There. So we make these things as part of the boundary so that our crossing points are less. Okay. So next time we will start with the example.